Problem number 1. If the viscosity of water at 70 degrees Celsius is 0.00402 Pa and its specific gravity is 0.978, determine the absolute viscosity in Pascal second and the kinematic viscosity in meters squared per second. We will always be starting by gathering the given quantities from the problem itself. So for problem number 1, a certain fluid, which is water, has a viscosity of 0.00402 Pa and has a specific gravity of 0.978. Since the problem does not directly say whether the given viscosity is absolute or kinematic, we may label it first as a general term viscosity to avoid further confusion upon solving the problem. So the required will be absolute viscosity and kinematic viscosity. Jumping to the solution, since the given viscosity was already in Pa, it can be assumed to be absolute viscosity. Take note that the standard unit of absolute viscosity is Pascal second, and the given was already in Pa. The Pascal second and Pa are already correlated by a conversion factor of 0.1 Pascal second equal 1 Pa. Thus, by multiplying the given viscosity by the conversion factor, we will arrive at the absolute viscosity of 4.02 times 10 to the negative 4 Pascal second. Since you have already come up with absolute viscosity, we may now move on into solving the kinematic viscosity. And the formula for the kinematic viscosity concerning absolute viscosity is shown in the screen in front of you. The kinematic viscosity is the ratio of the absolute viscosity over the density. Since the problem does not give the density, we may have to expand the equation shown so that we may incorporate the given quantities and thus being able to solve the problem. So upon further expansion of the equation, by replacing density as specific gravity multiplied by the density of the reference fluid, we will come up with this equation. 4.02 times 10 to the negative 4 Pascal second over 0.978 multiplied by the density of water, which serves as the reference fluid, 1000 kilogram per cubic meter, thus arriving at the final answer of the kinematic viscosity as 4.11 times 10 to the negative 7 meters squared per second. Problem number 2. An atomizer forms water droplets 45 micrometer in diameter. Determine the excess pressure within this droplet using the surface tension 0.0712 Newton per meter. We should always start with the given. So for problem number 2, water droplet formed from an atomizer with a diameter of 45 micrometer and a surface tension of 0.0712 Newton per meter. Remember that prefixes should always be expressed in its numerical value. So the diameter should be expressed as 45 times 10 to the negative 6 meters. What is being asked in the problem is the internal pressure or the excess pressure in the droplet due to the surface tension. So for the solution, the formula for the spherical droplet is given as shown in the screen. The surface tension is equals to the internal pressure multiplied by the diameter of the spherical droplet divided by 4. Remember that this formula is already given for problems concerning spherical droplets. So upon substitution of the given, we will arrive at this equation. The surface tension of 0.0712 Newton per meter equals the internal pressure multiplied by the diameter of the spherical droplet divided by 4, thus arriving at the final answer of 6,328.89 Pascal or 6.33 kilopascal.